Hello everyone, I am very glad to present our work, FinEvol-KR. This work is jointly completed by Ant Group and Shanghai University of Finance and Economics. In the world of finance, tasks are incredibly complex. Think about assessing a central bank's interest rate hike. This requires a deep understanding of professional knowledge, but also the ability to perform complex reasoning, like exchange rate mechanism analysis and market sentiment reasoning. The stakes here are extremely high. A single error can lead to significant economic losses. This brings us to a major industry pain point, that when a model performs poorly, we often can't pinpoint the root cause. This uncertainty is a huge barrier to improving these models and deploying them safely in the real world. That's why a precise evaluation of both knowledge and reasoning is so essential. When we examined the existing evaluation benchmarks, we found three critical limitations. The first is, they have inadequate capability decoupling. They typically rely on a single task accuracy score, which mixes together a model's knowledge and its reasoning ability. You can't tell which one is the weak link. Second, there's a lack of error root cause analysis. They tell you if an answer is right or wrong, but they don't diagnose why it's wrong. And finally, they often ignore the cognitive science perspective. Financial reasoning isn't just about applying a formula. It requires higher order skills like analysis and evaluation, as described in frameworks like Bloom's taxonomy. Current financial benchmarks simply aren't designed to measure this. To solve these problems, we developed FinEvol-KR. It is powered by a novel evaluation framework and a dedicated dataset. In the first stage of our framework, we give the model a question and it generates an answer. A judge ELM then reviews it. If the answer is wrong, we move to stage 2. In stage 2, we provide the model with the exact knowledge points that the judge ELM identified as missing. Then, the model tries to answer the question again. This brings us to stage 3, error diagnosis. Here, we compare the results of stage 1 and 2. If the model succeeded in stage 2 with the extra knowledge, we can conclude the initial error was due to a knowledge deficiency. However, if the model still fails even with all the necessary knowledge, we consider the root cause is reasoning ability deficiency. This process allows us to cleanly decouple and measure these two critical abilities. Our framework is powered by a new, high-quality dataset that we built. The example data can be found in this URL. This dataset is sourced from 9 classic finance textbooks, ensuring its authority and relevance, and it covers 22 different financial subfields, as you can see from the diversity in this chart. But what truly makes it unique is our rich annotation. Each of the nearly 10,000 question-answer pairs is tagged with its core knowledge points, a detailed step-by-step reasoning chain, and the cognitive level required based on Bloom's taxonomy. Finally, it has been manually verified to have an accuracy of over 90%. Our paper provides full details on the dataset's creation and validation. Our framework allows us to introduce 3 core evaluation metrics for a much more detailed analysis. The knowledge score quantifies the model's coverage of professional financial knowledge. The reasoning score measures the model's pure reasoning ability after we have isolated and removed the impact of any knowledge gaps. And finally, the cognitive score, which is based on Bloom's taxonomy, allows us to measure performance across 5 different cognitive levels, from basic remembering up to complex evaluating. Together, these metrics give us a fine-grained diagnostic view of a model's true capabilities. Then, what did we find after evaluating 18 leading ELMs? Our first major finding is that reasoning ability is the core bottleneck for performance. Specifically, we notice the models form clear performance tiers in terms of task accuracy. The knowledge scores for almost all models, except GPT 3.5 and FinR1, are very high. That is, above 0.8. This tells us that simply having more knowledge is no longer the main differentiator at the highest level. However, when we look at the reasoning scores, we see a significant performance gap separating the top two tiers from the bottom two. Models specifically optimized for reasoning, like DeepSeek R1, lead the pack. Our analysis confirms a strong correlation between this score and overall task accuracy. The key takeaway is clear. It is the sophistication of reasoning, not just the breadth of knowledge, that truly determines a model's success in complex financial tasks. To understand this reasoning bottleneck better, we took a deeper dive using our cognitive score, which is based on Bloom's taxonomy. We found that while most models perform well on lower-level cognitive tasks like remembering and understanding, there is a sharp and universal performance drop at the applying level. It's a fundamental industry-wide challenge. Models can often recall theoretical knowledge, but they consistently struggle to apply it correctly in practical scenarios. This is a crucial insight for anyone looking to build reliable, real-world AI systems. On the other hand, we observed a dilemma of specialization. One might expect that specialized financial ELMs would outperform general ones, but that's not what we found. Leading financial models, like Zhuanyuan, lag behind top-tier general models like Gemini 2.5 Pro by more than 20% across accuracy, knowledge, and reasoning. We attribute this to the inherent advantages of general models. Their vast multi-domain pre-training and faster development cycles give them a powerful head start in generalization that current specialized models struggle to overcome. Of course, the reliability of these results is paramount. We validated our framework by benchmarking our Judge ELM against human experts and achieved over 92% alignment. This high level of agreement confirms that our framework is robust, giving us strong confidence in our conclusions. For details of our validation methodology, we invite you to read our paper. So, how does FineVol-KR provide a path forward? It offers clear, actionable guidance for model developers. Using our decoupled perspective, developers can now diagnose problems accurately. If a model has a low knowledge score, the solution is to supplement its training with more domain knowledge. If it has a low reasoning score, the focus should be on optimizing its reasoning logic. For instance, by strengthening its chain of thought capabilities. And by using the cognitive science perspective, we can get even more specific. For example, if a model scores poorly on the knowledge application level, developers know they need to create training data that focuses specifically on knowledge implementation scenarios, like formula substitution calculation, quantitative analysis of policy impacts, and so on. To summarize, our work introduced FineVol-KR, a framework that, for the first time, achieves an accurate and decoupled evaluation of knowledge and reasoning for financial ELMs. Our core findings provide clear guidelines for the industry, highlighting that reasoning is the key bottleneck. For our future work, we plan to enhance the framework by introducing a multi-ELM judge mechanism to reduce bias. We also plan to expand our dataset to cover multimodal scenarios like financial charts and optimize the automated annotation process to make building these datasets easier. Thank you very much for your time and attention. For more details, please refer to the original paper or contact us via email.